Welcome back to Physics 101. Today, we will be discussing Chapter 12 on temperature and heat. For our first question, it's all about pressure and temperature. We are asked to find the pressure at the temperature which CO2 solidify, given only the pressure of a gas at the triple point of water, which is 1.35 atmospheric pressure. Before we solve this problem, we first need to know the relationship between pressure and temperature. We know that the pressure and temperature are directly proportional. As the temperature decreases, the pressure will decrease as well. The relationship would be given by the first temperature over the second temperature equals to the first pressure over the second pressure. At triple point, the water and the temperature is equals to 273 Kelvin, which is our first temperature. Given that the pressure of our gas at triple point of water is 1.35 atmospheric pressure, this would be our first pressure. While the temperature of where CO2 would solidify is not given in our question, we can find this with a little research, and we would see that the temperature of 195 Kelvin, it is when the CO2 would solidify. Plugging in all our values to our formula we discussed, and we would arrive to the answer of 0.94 atmospheric pressure, and that would be the pressure where CO2 would solidify. For our second question, the Humber Bridge in England has the world's largest single span of 1,410 meters. We are required to determine the change in length of the span of the Humber Bridge when the temperature rises from -5 Celsius to 18 Celsius. In this question, we are given the initial length of 1,410 meters and our initial temperature, which is -5 Celsius, and our final temperature, which is 18 Celsius. And our coefficient for linear thermal expansion is 1.2 times 10 raised to the -5 per Celsius. It is important to know that when the temperature increases, the length also increases. Knowing this, we would be able to come up with a formula, and this would be the change in length would be equal to the initial length times the coefficient of the linear thermal expansion times our change in temperature, which is 18 minus -5 Celsius. Be careful with our signs because they can be tricky sometimes. Now, let's plug in all our values to our formula, and we would come up with 0.39 meter as our change in length when our temperature changes from -5 Celsius to 18 Celsius. For our last question, now this is something really exciting because we are now applying physics in our daily lives. A US penny has a diameter of 1.9 cm. At 20 Celsius, the coin is made up of metal alloy, mostly zinc, for which the coefficient of linear expansion is 2.6 times 10 raised to -3 Kelvin. We are asked to calculate the new diameter in the Death Valley on a hot day at 48 Celsius and on Greenland at -53 Celsius. Now, the best way in solving problems like this is to first list all our givens in the problems. We are given the initial length of 1.9 cm and our initial temperature, which is 20 Celsius, and our coefficient for linear thermal expansion is 2.6 raised to -5 per Celsius. To solve this, we would follow the linear expansion equation, which is the final length, which is also the final diameter, which we are asked to find, is equals to the initial length, which is our initial diameter, times the quantity of 1 plus our coefficient of linear thermal expansion plus our change in temperature that would differ in the two places. Now that we have all the variables we need in our formula that we are gonna use, all that's left is to plug in the two different temperature at the two different places. First, at the Death Valley. Here at the Death Valley, our final temperature would be 48 Celsius. Now, plugging in all our values, we would end up with the answer of 1.9014 centimeter. Here in our second place, which is the Greenland, our final temperature is negative 53 Celsius. Here it is much colder. Now, plugging in our values, we would end up with a final answer of 1.8964 cm. After solving this problem, we can now conclude that on a hot day, the length of the diameter increases, and on a cold day, the length of the diameter decreases. Now, this proves the question we solved a while ago, that if the temperature increases, the length also increases. I think that's all the time we have for today. Thank you so much for listening. Hope I was able to help your physics journey. Tune in to more physics solving fun.